Hello and welcome to the first SQP tutorial. This is the first of 5 tutorials. In this video, we are going to explain how SQP can predict the quality of survey questions. In survey research, to measure a concept or variable of interest, we use an observed variable, which is obtained through a measurement instrument in a survey, namely a survey question. Often it is assumed that the observation and the variable of interest are the same, even though research shows that observations are always subject to measurement error. If there is measurement error, the relationship between the two is no longer perfect. Measurement errors can be random or systematic. The presence of random errors means we need to distinguish between the true score and the observed variable. The true score is the observed response corrected for random errors, the true response to the survey question. The standardized effect between the two is called the reliability coefficient. Systematic error affects the relationship between the variable of interest and the true score. The standardized effect between the two is called the validity coefficient. The resulting model is the true score model as developed by Saris and Andrews. The quality of a survey question is the strength of the relationship between the variable of interest and the observed answers. It can be computed as the product of the reliability and validity. In order to estimate the quality of survey questions, the multitrait-multimethod approach was proposed by Campbell and Fisk and developed further in particular by Saris and Andrews, who proposed the true score model presented above. The MTMM approach consists of measuring several related concepts by asking them multiple times using slightly different methods, for example, different response scales. For identification purposes, the most common design is a 3-trait by 3 method model, like the one presented in the picture. For example, let's imagine that we want to measure a variable of interest about satisfaction with the economy. The question would be first asked using method 1, a response scale from 0 to 10, where 0 is extremely dissatisfied and 10 is extremely satisfied. After this, it would be asked using the different response scales from method 2 and method 3. The same procedure would be repeated for 2 other variables of interest. However, the MTMM procedure has some limits. First, there are some disadvantages related to the respondents. These are memory effects and the cognitive burden of having to answer the same questions at least 3 times. In order to limit to 2 the number of repetitions for each respondent, the split-ballot MTMM model was proposed by Saris, Satora, and Coenders. The feasibility of MTMM experiments is also limited by the disadvantages affecting researchers. It is not possible to repeat every single question in a survey. The questionnaire can get too long, the process can be extremely time-consuming, and it can also therefore get very expensive. The survey quality predictor software was developed to deal with these limitations. The development of SQP started in 2002. The first step was to collect all existing knowledge about the quality of survey questions based on previously conducted MTMM experiments. This process generated a lot of knowledge about the quality of survey questions on different topics, including questions fielded in different countries by many different survey agencies. In particular, each of the first 3 rounds of the European Social Survey included 4 to 6 MTMM experiments. In total, the quality of 3,726 questions was used in the development of the software. The second step was to identify and code the characteristics of all these questions. Among the list of formal and linguistic characteristics are, for example, the domain, the balance of the request, the presence of an interviewer and respondent instructions, and the linguistic characteristics of the question. Overall, the coding process consists of 30 to 60 characteristics, depending on the level of complexity of the question. Finally, combining the 2 steps, the set of characteristics of each question in more than 20 languages and countries could be related to its estimated quality. Then, in order to be able to predict the quality of new survey questions, a meta-analysis using random forests of regression trees proposed by Bryman was adapted to SQP 2.0 by Oberski and Saris. This approach was based on constructing multiple regression trees, each with different sets of characteristics that were maximally different depending on the reliability and validity estimates. It generated good predictions based on the average of the multiple predictions obtained by the random forest of regression trees. After all this research, the program SQP 2.0 appeared in 2012 and since then, the quality of new survey questions can be predicted by coding their characteristics. Thank you for your attention. If you want to know more about SQP and learn how to use it, please go to the next tutorial.